In this video, I'm going to explain the concept of logical equivalence. And to do that, I'm going to use an example. So the example we're going to use is we're going to show that the statements not P and Q and not P or not Q are logically equivalent. To do this, we're going to use a truth table. And in our truth table, we're going to build up to this statement and this statement. Now, remembering that a truth table, in a truth table, we want to exhaust all possibilities, and we're going to build up to these two statements. So we're going to start with P and Q, and to build up to this thing, we're going to need a not P, we're going to need a not Q, and then finally a not P or not Q. To build up to this one here, we're going to need a P and Q, and then finally a not P and Q. Now remember that in a truth table, we want to exhaust all possibilities for truth and falsity for P and Q. So we're going to have true, true, false, false, true, false, true, false. So now looking at this column, to fill in this column here, right, this is the negation of P. So when P is true, in this column we have a false, and when P is false, in this column we have a true. So we have false, false, true, true. Similarly, looking in this column, we're going to fill in this column as the negation of each of these. So we have false, true, false, true. Now putting together these two columns with an or, we have false or false gives false, false or true is true, true or false is true, and true or true is true. Now to fill in this column, we're going to look at the and of this column and this column, P and Q. So true and true is true, true and false is false, false and true is false, false and false is false. And now lastly, to fill in this column, we negate everything in this column. So the negation of true is false, the negation of false is true, the negation of false is true, the negation of false is true. And so now looking at so remember that we wanted to show that this and this are logically equivalent. So two statements are logically equivalent if no matter what assignment of truth values, you get the same values, same truth values in their final columns. Now look, notice that we have false here and we have false here. True and true, true and true, true and true. And so notice that all of these values are exactly the same as all of these values. These are the same. So when we do a truth value like this, or a truth table like this, and no matter what our assignment of truth values over here in these columns for our basic statements being like P and Q, as basic as you can be, and then we would build up to more complex expressions with these P's and Q's, as we have here in the red and blue. No matter what assignment of truth values we have here and here, we get the same truth assignments in their final columns. This tells us that these two propositions are logically equivalent. Same, this means that these statements are logically equivalent. So logically equivalent means that they say they have the same truth values. And so in a sense they're equal. But equals doesn't work for logic. Equals works for numbers. So instead of writing is equal to not P or not Q, instead of writing that, so this is the idea, right? Putting equals there, that's the idea that these things are basically the same because they have the same truth values. The same truth values, their same final truth values. But because equals only works for numbers and it doesn't work for logic, we use a different symbol, but you could think of it as equals for logic. The equals for logic, we just add another line there. And so now we have proved this. And what this says in the white box is that not P and Q is equivalent to not P or not Q. This is one of De Morgan's laws. You'll prove the other De Morgan's law in the homework.